I'm back with another video, another repair video. But this one is a little different. So let's have a look what we got on the bench today. Come on in a little bit here. Hey, there we go. So this is out of my buddy's stove. And what it's doing is the relays that control the burners, which are these guys here. One, two, three, four burners on his oven. The most used one is actually staying on even after they turn the dial off. And we kind of had troubleshot it down to this point because he had the back off and stuff, and I'm yakking to him as he's doing his thing, and I'm like, okay, go down, follow this wire, go down, and eventually we got down to this board, and I said, okay, it's still on. Yes, I said, okay, give that board a little bit of a whack on those black guys, right? Thinking in my mind, I'm thinking, okay, one of these are probably stuck, and that's exactly what it was. As soon as he hit one of these things, the oven light went out, and then he turned it back, put power back to everything, and it was clear until he turned it back on. When he turned it back on, it got stuck again. So I have a feeling we just have some bad relays. I told him, I mean, if you're going to go out and replace one, you might as well replace all of them. So, that being said, went out and he sourced 4 new ones. Right here. So the job today is going to be to take these guys off and put these guys on. So we'll just get these out of the way for now and have a look and see how much of a pain in the butt this is going to be. If I'm lucky, this is lead-free solder. Or this is leaded solder. God, I don't know why I can't get that right. So, anyways, I think what I'm going to do is I'm just going to try wicking those holes first and see if I can get any traction. I could bust out my solder sucker too. I have a pretty decent one. I don't have one of those, the electric heat up ones, the independent ones. I don't know. I've seen some really good results from those things, and then I've seen a lot of like nightmare stories because it seems like those things have a high potential of clogging, which I mean we all kind of know that does happen. So
So this is where pretty much audio died, and yeah, so I'm going to walk you through on a little bit of a tour instead. Right here, I'm getting ready to put the Steery flux onto the board here. I'm going to apply it everywhere. I found I had to really squeeze that out because usually I'm working with smaller components and not putting flux on hole-through components, but yeah, I mean it works good on everything. That's why I like Steery Flux. I don't like it for the final laydown on SMD chips and stuff like that. I find it burns away too fast with the heat. So yeah, so I'm gonna go ahead and try and remove this stuff with some wick at first, and I did find that when I was wicking, it just was making so much smoke, and you'll see here once I get going that the iron is fantastic. It's amazing how much heat it can deliver to that tip, and I mean, it was definitely smoking, but it wasn't really working like I wanted it to. So I did this for a couple minutes and just tried to let the heat soak into the wick, and I did pick up a bunch of solder, but it just didn't. Um, it didn't clean out the hole like I wanted it to. Like I was hoping it was going to be easier or faster than it was, because like I was obviously I wanted to do this quick. And I looked at it and I'm like, okay, let's bust out the solder sucker and see if that's going to work better. Now I do have one of those solder suckers, the smaller ones, and they work really, really well. Um, it's it's a little bit small for my hands, and it does clog up faster than the bigger solder suckers, but they're super powerful. So I decided, hey, like maybe I should just try this and see what happens. I have had relatively good success when I do use it. I just don't prefer to use the solder sucker over wick. I usually would like to have wick um, do most of the work, but in this case, I was like, okay, let's try it. The solder suckers do work ideally better on hole through style devices, so I was like, okay, let's give it a go. So turns out, it started to work really, really well. The iron can really get the pins hot enough so it just, basically heats up the pin, heats up the pad, and it was just a matter of kind of just getting the solder sucker. Just a couple test fires first. I think I did just recently clean it, so it should be fairly good inside. This definitely didn't do any favors, that's for sure. But yeah, it's a 8 pin. Um, sorry, 6 pin that holds it on. Two on the top and four on the bottom. And each one there's four of them on the board. So of course I wanted to try and get through this to see if it was gonna work, and I was just kind of messing around with it, and I noticed that it like pretty much like felt like it was free, like it was moving. And I was like, "Oh, okay, well, let's keep going with this bad boy." So that I just kept going, and it actually felt like it went really quickly because it was um, just put the iron down, hit it with the pump, hit the next pin, hit it with the pump, and just keep going. And you'll see as soon as I'm done these first 6 pins, I'll get underneath it and I'll like literally it'll come right off the board. It's kind of funny, because I wasn't expecting to come off that easy. Yeah, just like that. Oh, boom, off. So that's the first one. So basically rinse and repeat, right? So um, yeah, it was easy enough to do with like basic tools. I mean, I don't know, the iron itself, which is the uh, Axion TA, I think it is, if I remember correctly. Yeah, TA. Uh, it's like the JCB iron style, right? With the heat tip that's like built in right into the iron tip. Works really, really good. Apparently, you can put the JCB tips into these things. I haven't even tried to order that yet because I'm honestly still running off of that same tip, which is amazing. Because I mean, most of the time stock stuff is garbage and it doesn't work very well. But this one, um, it's holding up well. Like I keep it tinned and make sure the tips isn't out of the holder longer than it needs to be, because once it's in the holder in this thing it does that auto cool down too, right? So yeah, it does it works really good. It heats up within like 10 seconds, and well, actually faster than that. It's more like 5 seconds. You don't really notice it by the time you have it out of the cradle and you start to use like it's pretty much up to temperature. So yep, it was that easy. I couldn't believe it. I was just like, oh, okay, well, this is cool. This is not going to take long at all. So yeah, the way that he initially had diagnosed this thing was just by using the stove and trying to figure out what was happening. And he phoned me, and I kind of did. I've had a similar situation with an old stove of mine, but the board was a little different where the power boards were. But in that case, it was the same thing. In the reverse, the power supply, or not the power supply, the relay actually blew off the board. One of the legs like blew right out of it. It was like a crappy solder joint probably from the factory, and it just arced and arced and arced, and then finally let go. And so, I've I've had some prior repair with these appliance boards. They're kind of a crappy quality usually. Um, this one seemed to be pretty good. I just think because they use that burner all the time. It's the main burner, the one, everybody knows which burner it is. The one that everybody it has the most power and usually is, the largest circumference as well, so it can do the big pots and stuff. Those are the ones that everybody uses. So like this relay in particular, I think this is it, the actual failed one. Um, it was, that's the heaviest used relay. So over time, yeah, of course, you're pounding voltage through it, and for however long, and if a stove is pretty on off, you use it all the time. So yeah, I'm like, I did this one a little bit too fast. I remember. I'm like, damn it, it's not coming off. I gotta redo it. So, yeah, I just kept going at it here, just doing my thing, and just letting the tools work. Cause like really, if you get the solder sucker right over the pin and it's hot, it usually pulls the entire piece that's in there that's holding it. Well, you saw the first couple. You can literally just pull the components out and cleans it out that well. They come with a little silicone uh, piece on the end of it, and that's what actually kind of it touches the board. I bought a whole bunch of extra hose actually for it. You can buy the tips, but I mean it literally is just silicone hose. So um, you see me cleaning it up here a little bit. The flux, there was quite a bit of flux on the board. I kind of went a little bit overboard, I think, with the amount I needed, but I wanted to make sure that I was getting like maximum heat transfer to make sure that the holes were having the best chance of coming out. Because yeah, I've struggled with hole through before. I'm sure everybody that plays with electronics knows what I'm talking about. Like you think you're gonna get it cleared and it's just gonna come out, and it ends up being a nightmare and taking forever just to, you know. So every once in a while I have to do that to that plunger because it um, kind of gets a little clogged up. It's sucking up a lot of flux too, so it's not helping it. But yeah, I thought this went really really fast as far as the removal, the whole process. That I kind of had thought to myself this was going to take like at least an hour to get everything off, and then putting it back should be pretty quick. So I had given myself like an hour and 20 minutes to do it, and then this just literally just popped off super, super fast. So I just let the tools do their thing. Tried to clean up a little bit. There's flux getting everywhere. It was brutal. Um, I just kept cleaning up as I was going here and picking up all the garbage. Just use a little bit of IPA here with my spray can, and then just wipe it up with the paper towel. Works pretty good. It's something I could just do really quickly and keep everything perfect. So there's the last one out. I was like, oh, sweet. Wow. And then you look at it and it looks all good. You just grab the new one and it's off to the races, because basically all I did here was the strategy was just to tack the two, like the top and bottom corner of each one so that it was holding, and then I came back after the fact with the iron, actually soldered everything in. So just kind of eyeballing it all up, kind of getting everything prepped. I got my solder ready there. I thought I had enough. I actually run out, and I'm like, yeah, you go through a lot more solder when you're doing this kind of work. But yeah, just grab it off the bench there, just heat it up and get it onto the tip, and then just take it over and hit two legs at a time. Next one, once it's stuck there, it's good, right? So grab another one, do the same thing. Really important, of course, that you get those flat to the board so they're not all uneven and stuff. You want them to sit just like they did before, just nice and flat and no ridges and no. Because really, these relays are what's actually carrying your power. So like the power that's coming out of your wall is going directly into those heating elements. So those are what's handling that power switching is that in your oven. Do you think the other two that are in there are probably the oven elements? You think you might want to try to change that one too, because he said something about some weird temperature thing going on with it, or I can't remember exactly, but it could be relay related. I mean, if they stick, then and they don't, if they don't return to the way they're supposed to, then yeah. You don't usually see that on relays. You usually see it the opposite way. The opposite way is they fuse because they're too much power or they're um, not soldered properly on the board. In the case of the one that I had, it was literally just the leg. You could see the other solder on the pins. It was not securing it at all. And that's, I think over time, just the power constantly going through the board and the relay just eventually, yeah, zapped it right off it was black. The whole underneath of the board was like this big, like, pow streak. Oh, yeah, here. This is when I was like, this flux is pissing me off. I gotta get it off the board. Yeah, for larger amounts of soldering and whenever you're doing, big areas, I go through a lot of paper towel. Just cheap, regular paper towel. It works perfectly good. It soaks up IPA and water and anything else you want to put on it. I use a lot of Windex. I think I've mentioned that in the past videos. Windex is a really good cleaning thing you can use too. If IPA isn't working, Windex works every single time. I'm just getting everything clean there, and now I'm just gonna go in, and this doesn't take me any time at all. This is so fast because you're just going from pin to pin with the iron, and yeah, it's super super quick. I love iron. I love this iron. This iron is like definitely the nicest one I've ever had. It's super super nice to work with. I think I had my temperature set at 420 on here, so it was hot. Um, but I wanted it a little bit warmer just in case. You can see I'm working on ground plane here. You see all the ground trace everywhere. I mean, the board's not as heavy as like an Xbox One or even in a Series S or something like that. It's just still it takes up a lot of heat out of the tip. But man, oh man, that iron just it doesn't care. It's just like, oh, heat. You want more heat? I'll give. So yeah, basically just go through really, really quickly and make sure I get all the pins on each one. You can see here, this is where I'm starting to run out of solder. I'm like, kidding me? I'm not gonna get this whole thing done. Uh, yeah, I was right at the end of the line there. I did use it all. Luckily, I do have lots of solder, so it's not a problem. But it's just funny because that was a good, I would say, 8-inch piece of solder there. But just you go through it so much quicker on these kind of boards. I'm used to the smaller stuff now, where just a tiny, tiny, tiny bit is all you need. A little bit of touch up here, and basically that was it, right? Like it was really quick, and I phoned my buddy, or I just texted him, I guess, and I'm like, hey, it's ready. And it was like literally, I think this took me like 20 minutes. It was super, super quick. So this kind of repair actually is pretty common on appliance boards, especially the power stages of boards, dishwashers, stoves, fridges, all that kind of stuff. They all have switching power boards. You know, you've got in the dryers and appliances, you've got 240. Stoves have 240, so you know there's a lot of power potential there. So these boards can be easily repaired. Usually, you just need to know what you're looking for. In this case, we're looking for the relays, and you know, I just told them like let's do them all and see if that's all we need to do. And if that's it, then you know you've got a stove that you don't have to go replace. I think a new stove is around 1,400 bucks Canadian, in like the Home Depots or whatever. So I mean, for a couple bucks and a buddy that's willing to shoot a video and put it on YouTube and show everybody how cool it is, all brand new. That's it. So thank you everybody. Have a great one, and thanks for stopping by. We'll see you on the next one.